Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we are starting another sum of AFD, SFD and BFD which is come in the exams. Very important. In this sum we have to find the inclined load over the UDL with inclined load. With the UDL we have to transfer the load in the inclined member. Let's see how will you transfer this load into the beam. See, this is your question given in the exam. See, the question is given, draw AFD, SFD and BMD of the given frame. Okay, now what we have to do is over here we have to find this we have to find VA, this is VC and this is your HC, this is your HA. Since both are hinged, that's why it's indeterminate structure. To determine the structure, we have given the internal hinge over at point B. Okay, we have given the internal hinge to determine the structure. Okay, now in this types of problem, there are two cases in this types of examples comes in the exam. There are two cases. Let's see what are the two cases. It's not I'm not solving the sums now. I'm just explaining the two cases which is a possibility to come in the exam in these types of sum. See, as an example, see, first case is like this. Our triangle will be there. First will be like this and the another will be like this. Now we are solving this type of sum. This is also possible to come in the exam. For example, let's see, we have to solve first this one. What we have to do, we have to this UDL W, this UDL will have to this UDL we have to rearrange in this beam. Okay, how will you this arrange? See, they have a certain formula given in the exam, given over here. See, what is, draw the FBD of that part. Simply this W will to rotate into this W will put it in this beam like this, and this formula will come W cos square theta. Please remember the formula over here. This will nothing but W cos square theta. Since W is going from this to this, that's why there also have to come this UVL. Okay, and this formula will be W cos theta and sin theta. Please remember this formula first. Okay, now in this case, this is case 1 and this is case 2. And what the case 2 says, the case 2 says we have to this UDL we have to put it over this member. Okay, now how will you put? See, directly draw the UDL and this formula will be W sin square theta. Since he's going this direction to this direction, that's why UVL will come over here like the upward, as formula will be W cos theta and sin theta. Please remember, in the exam these two cases are possibility to come in the exam, so we are solving this case now. Okay, now our formula will be like this. See, this case we are solving this case. This member is important, this will is solved by own also. See, now how will you solve this? First what we have to do, our first step is nothing but to calculate the support reaction. Okay, now solve the support reaction. Please remember, these are the two cases, it's not a sums. Okay, we have to just remember this formula is W cos square theta, W cos theta sin theta. In this case W sin square theta and W cos theta and sin theta. Okay, now let's start with the sums. Our first step is solution. Our first step is nothing but support reaction calculation. For support reaction calculation, what we are taking first, we are taking to find VC, we have taking moment at A equal to 0. Now taking summation moment at A equal to 0, taking moment at A equal to 0 clockwise positive. Now how will you take like this? See, Says 8, put a rod over here and apply load from up to downward like this. This, for example, this is a UDL. This is rotating clockwise direction. So this will come 8 into 3 into 3 by 2. 8 into 3 into 3 by 2. Okay, this is your load and this is your total load into that distance. Okay, after that there is no load, directly we have to come with unknowns. See, now this will go like this. This is anti-clockwise, so VC into this distance, and this distance will be 6 meter, minus VC into 6 equal to 0. While solving this, you get the value of VB value will be 6 kilonewton. Okay, your VB comes in the 6 kilonewton upward. Okay, now see, what is our next step? Our next step is nothing but summation Fy equal to 0 upward positive. Okay, now what's come in the picture? See, we got the VC value 6 kilonewton, put it over here. Now see, this is minus, this is plus, this is minus, and this is plus. So VA minus 8 into 3 plus 6 equal to 0. While solving this, you get the value of VA. Your VA value will be 18 kilonewton upward. Okay, this is a very basics. Now we are done with this too. Okay, we are done with this too, but now we have to find this HA and HC. HA and S is a symmetrical, so both H are same, and for finding this we have to take the bending moment over at B as you solve in the arches. Okay, now see, if you are taking bending moment over here, bending moment at B, either you can take this part or you can take this part. So what we are convenient for us, we are taking this part because there is no complicated and no low load. Directly we see 6 into 3 will come. Okay, now see how it will take. Bending moment at B equal to 0. Follow this sign convention, positive. Now see, we are seeing we are taking section over here, and then we are seeing like here this side, left right side. So this VC will be go like this. This is hugging moments. Okay, now 6 into 3 plus 6 into 3. Okay, now see, now this H will come. See, take your this member will be like this, so your H value will become over like this. Okay, so this will, from we are taking section over here, from section we are taking seeing left side, so left side will go this direction, means hugging, so this will come minus, then minus HC into C. Now see, this is your HC. Okay, in HC we get the value of HC into, now what is the perpendicular distance of HC? The perpendicular distance will not be 3, the perpendicular distance will be 4. Now HC into 4 is equal to 0. Now while solving this, you get the value of HA equal to HC is equal to 4.5 kilonewton. Because of symmetrical. Okay, now we are done with the first part. Now this will come 4.5 kilonewton. This will also 4.5 kilonewton. Now see, we have done with the first part. Now see, we are calculating all this value HA, VA, HVC and HC. Now what is our next step? Our next step, we have to consider the separate part and draw their AFD, SFD and BMD. Let's see how it's come. Consider part AB first. AB first. Okay. Now see, we are solving this our question will be our of first case, so we have to resolve the member like this w cos square theta, w cos theta and sin theta. Okay, so please remember these things. Now first draw the FBD of that part. Square theta. Okay, now this UV also is coming, w cos theta sin theta. Okay, now see, we know the value of this and we know the value of this also. Now see, now what you have to do, now see, just for this types of problem, see, we don't want this this direction, we want the with respect to the beam. For example, this is our beam, we want the axial force like this and vertical force like this. Okay, so in this we have to resolve the member in sin theta, in terms of sin theta and cos theta. So at that time, first of all, we have to find the theta. Now how will you find the theta? Now we'll find the theta. To find the theta, you know that tan theta, to find theta, write it over here. To find theta, tan theta is equal to opposite upon adjacent. Upon opposite will be 4 meter and adjacent will be 3 meter. Okay, therefore theta is nothing but 53.13 degree. Okay, this is comes with theta. Now what you have to do after that, we have to just simply apply the formula over here first. See, this is w cos square theta. Now what is w? W is given in the question, this is 8. So just put the value 8 cos square 53.13, 8 cos 53.13 sin 53.13. Okay, now while solving this, you get this value 3.84 kilonewton per meter, and this value will be 2.88 kilonewton per meter. Okay, after that, see, now we have to find the theta. We have got the value of theta. Now what we have to do, we have to this resolve the member in axially or vertical and horizontal with respect to this inclined member. At that time, what I have to do, at that time, just simply extend all the members like this. See, just simply extend all the members like this. See, extend this over here, extend this one, extend this one. Okay, now perpendicular to this. Now see, now at that time, what is this? So for example, this is our theta, then one and another is our theta. This is also theta, this is also theta, and this is also theta, and this is also theta. This one is also theta. Okay, now see, we have to just extend all the members. Now what we have to do, just 18 kilonewton, this 18 kilonewton will be put it in this direction and this direction, and this 4.5 will be put in this direction and this direction. Now I am explaining in here only. Okay, see, just okay. Now see, this 18 will be, when this 18 will be come over here, this value will come 18 cos theta, 18 cos theta, because this with respect to and with respect to theta, so that's why it's cos theta. So see how it will come, this will come over here, 18 cos theta. Okay, now see, now when this 18 will be come over here, from with when your this theta 18 will come over here, there are no theta, that's why 18 sine theta. It's like this, 18 sine theta. Now when this 4.5 come over here this direction, then when your 4.5 come in this axial direction, means this with respect to theta, that's why it will come cos. So this will come over here 4.5 cos theta. Okay, now this 4 point will come over here, this will come sine theta, like this, 4.5 sine theta. Okay, now find all the values. This will come 7.2, this will come 3.60, this will come 14.40, and this value will come 2.70. Now but in exam we don't want this 4 values, we only want one this direction value, one in vertical direction, one in horizontal direction with respect to the beam or angle, beam with respect to the beam. Okay, now what we will do, see, now how will you convert this UVL into point load in this type? We convert the load, we want this distance. How will you find this distance? As you all knows, by Pythagoras theorem, L is equal to, see, L is equal to under root of 4 square plus 3 square is equal nothing but 5 meter. This distance will be 5 meter. So this you convert this UVL into point load. So directly into this 3, see, 3 directly convert into point load, 3.84 into 5, we got the value is nothing but 19.2. This will convert into point load, only one point load. Okay, now we don't want these 4 values, we want only x direction and y direction 2 values. Now arrange it, add it both one. So this she mean I will draw one and again, see, this one is like this. Okay, now see, this will going this direction, this also going this direction, means both are same though. So addition of these two means 14.40 plus 2.70 means how much is value comes 17.10, means 17.10 is going like this, 17.10 kilonewton is going like this. Now see, this 7.2 going up and this 6.3 is going down. So this 18 cos theta, this value will be 10.80, not 7.002, this 10.80. now see, 10.80 is going up and this 3.60 is down, so 10.80 minus 3.60, it will come over here 7.2 kilonewton. Now we want these two values only, we want only these two values. Okay, now we want only these two values. See, now draw the diagram and draw the AFD, SFD and BMD. Now how will you draw? See, draw out here. Now see, now we have drawn the diagram. Now see what we have drawn. See, we have drawn this main one, this 7.10 and 7.2 kilonewton and 17.10 kilonewton. After that we have drawn the UDL and UVL plus this two. Now we have to balance this member. While seeing at A, we have to balance the part B. Okay, balance the part B. Now how will you balance? See, how will you balance like this? See, this 17.10 is going from this direction, in this type, in this sum you cannot directly apply 17.10 from this side also. Why? Because there have a UVL over here 19.2. so what we have to do is, see, 17.10 is going this direction, so positive. This one going from this direction means negative, means 17.10, then 19.2. How it come? It will come 2.1 and 2.1 will go upward here. This is 2.1 kilonewton. Now why it is going upward? Because see, 17.10 is going this direction, 2.1 is going also this direction. 17.10 plus 2.1 means 19.2 going upwards this direction. So 19.2 will come downward direction. This member will be in the equilibrium. After that, see, 7.2 kilonewton going upward. Now 2.88 into this distance is 5. 2.88 into 5. How it comes? 2.14 14.4. Okay, now see, this 2.88 into this distance is 5. When we are entering, that value will become 14.44. see, 7.2 is going up and 14.4 is going from up to down. So to balance this, we have to apply over here also 7.2 kilonewton. Okay, now this part is also get balanced. Now extend this part and draw the AFD, SFD and BMD. Okay, now our first part will be AFD, means axial force diagram. How will you draw the axial force diagram? See, first draw the beam. This is your beam. Okay, now see, it's not in the same direction. In previous questions, when we are solving the previous sums, we got the only compression or tension, but in this point we go to compression, and this also going for compression. So what will we do? We have to see the sign convention. See, the sign convention of AFD's axial force diagram is, see, this is a sign convention. Positive means we are taking section over here, and we are taking this side. This will go minus, and we are taking section over here, and from seeing this side, this will go plus. So this will come minus and this will come plus. So minus sign means inside the frame. Minus 17.10 will come over here, and there is plus 2.1 come over here. Now join all this, do both of them. Okay, take a section here only. Okay, we are taking section over here, and we are seeing this side. This will come 17.10 minus, we are seeing this side, it will come 2.1 kilonewton plus. Okay, minus means you have to draw inside the frame, and plus sign means you have to draw outside the frame. Okay, now this is your AFD part, axial force diagram. Okay, now we're done with the first part. See, write it over the value over here, 17.10, and this value will be 2.1. Now we have to draw the shear force diagram. After that, we have to draw shear force diagram. Now let's see how it's drawn. As you all know, to draw the shear force diagram, first we have to draw the beam like this. Okay, now after that, what I have to do? Take a section. See, in axial force also we are taking section over here and here, and from shear force diagram, shear force A at left equal to 0, shear force A at right equal to, and we are seeing over here means it will come positive 7.2. Positive 7.2 come over here, and when we are taking section over here, just left and seeing right side, only come 7.2, which is come minus, will come over here. Okay, now joint all two. This is 7.2 plus, and this is 7.2 minus. This is minus, this is plus. When you not understand, you can directly draw the diagram to solve the AFD part over here also. Okay, this is your part A, this is your B, this is A, this is B. Okay, now let's come with the bending moment diagram. First you have to draw the beam. This is your A part, this is your B part. Okay, now what I have to do, now see, as I'm saying again and again, for bending moment diagram always see the original figure. For bending moment diagram always see the original figure. Now we have to find bending moment at A and bending moment at B. Okay, bending moment at A will be 0 and bending moment at B will be as you are calculated in previous one. Bending moment at B will be, we are calculated, not we are not calculated, so we have to calculate all these values. Okay, now see, bending moment at B will also 0 and A will also 0. Why B is 0 directly coming? Because B is a internal hinge. Okay, now write it over here. Bending moment at A equal to 0, bending moment at B equal to 0 because of internal hinge. Okay, now where shear force 0, where the shear force is 0, the bending moment is maximum. So first we know we have to take section over here. We know this distance is x and this distance will be 5 minus x. Now we have to find this value x by similar triangle. Okay, now find the value of it by similar triangle. As this, see, this is 7.2, this also 7.2, this will come 2.5, this also come 2.5 because of symmetrical, or you can find by similar triangle. Now we want this value over here. Okay, we want this value. The total distance will be 5, means this one is 2.5, this one is also 2.5. Now name it as over here, this part will be D. Now we have to find bending moment at D. Now what is the bending moment at D? We are taking section over here. We are seeing here, see, this 7.2 into this distance will be 2.5 positive. 7.2 into 2.5. Now this UDL will come minus 2.88 into 2.5 into 2.5 divided by 2. While solving this you get the 9 kilonewton per meter. Get the answer. Bending moment at B will be 9 kilonewton meter. Now so this, where the shear force is maximum, bending moment, shear force is 0, bending moment is maximum. Now draw the diagram. This is your positive sign, that's why this is parabolic curve. Then now this is your AFD, this is your SFD, and this is BMD. Okay, now we have done with the first part. See friends, we are done with this first part, A and B. Now draw the FBD of the part B and C and draw AFD, SFD and BMD. Let's see how it will come. Now consider part B and C. Okay, now consider part B and C. Draw the FBD of the part first. Draw the one first FBD of that part. Now see, we know this value 6 kilonewton and this value. Now this from the here also we have to do same thing because we want x and y direction. Just extends all the members. See, this will your theta, this is your theta, this is your theta, and this is your theta. These all are thetas, as your alternate angles are same. Now see this 6 will be resolved, when with this 6 will resolve over here, this value will come 6 then this will resolve over here. See, this with respect to, not with angle, so that's why it come, what will come, it come cos, sine, sorry, it comes sine. With respect to angle means, with respect to angle is nothing but cos, with not respect to angle is sine. Now this when this 6 will go this side, this will come over here, okay, this will come 6 sine theta, okay. Now then this 4.5 come this side, will come 4.5 cos theta, because this is with respect to angle, okay. Now see, when 6 will go over here, this value will come like this, 6 cos theta, and this will come, when this 4.5 come in this line, this will come 4.5 sin theta, because this is not respect to theta, angle, okay. Now draw the final one. See, now put all the values. This value you got, this value is nothing but 3.6, this value is 2.70, this value is 4.79, and this value is 3.6, okay. Now this balance this part over here. Now write it in the next sum, write it in the next page. See, this will going 4.79, 2.70, means this all will come 4.79 plus 2.70, it will come 7.5. So 7.5 come over here. This is your main, this is our 7.5. Now see, this is going 3.6 up and this is going 3.6 down, means it will come 0. So this value will be 0. Now we have to balance this. To balance this, 7.5 coming from this side, to balance this we have to come in this here 7.5, and this will also 0. Now extend all the terms. Now draw the AFD, SFD and BMD. Now see, first part is AFD. See, this is compression. Compression means it's minus. Compression means minus. We are drawing minus inside the frame, so it will come over here. This is your this is your B. This is C. Inside the frame, minus sign. This is your AFD. Since there is no vertical load in the x direction, so shear force will 0 and bending moment is also so 0, okay. And this is your final answer, okay. Now see, we have done with this part. We have done this question. Now draw AFD, SFD of this member. An exam you have to ask from UDL over here also, okay. And this for when UDL is here, apply the second case. Now I hope you will understand my videos. Thanks for watching and subscribe the Ekeeda channel. Thank you.